In video 2 for Unit 8, we're going to further analyze the graphs of functions. In particular, we're going to determine zeros, something called end behavior, extremes, and the interval behavior of different graphs of functions. All of the graphs we're going to study will be functions, meaning they will all pass the vertical line test. To start, let's talk about what a vertex is. A vertex is, as we look at the skill we're learning today, an extreme. It's going to be the very top or the very bottom of the graph, but there's more than one top or bottom. Functions have peaks and valleys. The peaks, thinking about the mountain ranges, there's multiple peaks to a mountain range, not just one. Sure, there's one that's the highest, and then there's multiple valleys, one that's the lowest, but there are multiple valleys, multiple peaks. In algebra, when we're studying functions, we call those peaks maximums, and we call the valleys minimums. Because there are so many of them, as you look at these two graphs, they curve multiple times. You look at this first one, there's a valley, peak, valley, and it goes up. Or in the second one, peak, valley, and then it goes up. That means that there are multiple maximums and minimums. When we look at them, we actually call them local. So I would call this point here, since it's at the bottom of the graph, a local minimum. And that any time I have a peak, I call it a local max. And then another valley, that's another local min. This had two local minimums, one local maximum. In the graph on the right, I have two local maximums. It's a local max, and that's a local max. And I have two local minimums. What about these arrows? Here, 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 and here. Those don't get counted as maximums or minimums, because what those represent is that this is going to continue, this is pointing up. It's going to continue going up forever and ever and ever. Continue going up, up, and this one continue going down forever and ever and ever. They're not considered maximums, they're not considered minimums, because they don't change direction. Those maximums and minimums only happen when your function changes direction. Goes from going down to going up. That change of direction is an extreme, it's a vertex. So we would just make sure that we point out that the arrows don't count as local maximums or minimums. So what do those arrows count as? And that's our next section. That's where we get our end behavior. The end behavior is asking, how is the graph ending? What is happening at the end of each graph on both sides? We determine which side we're talking about with these two statements. As x arrow negative infinity, we would read this as saying, as x, that arrow means approaches negative infinity. Well, what does that mean? You can't approach a negative number, you can't approach a negative infinity, and in fact you can. That just means is as the graph moves left. So as it moves left, I'm considering my x-axis here, and as I'm going towards negative infinity, the left is negative infinity. What's happening to the graph? So if I look at this last question here, as x approaches negative infinity, f of x approaches what? This means the graph is going where? And the answer to these questions, when we are talking about infinity or negative infinity, is also infinity or negative infinity. A little bit confusing, but kind of bear with me here. If I always start and like kind of put my pencil at the origin, and I see as x approaches negative infinity, that means go left. Follow the graph all the way to the left until you get to the arrow. When you get to the arrow, were you going up or down? As I'm going left and I get to the arrow, I am moving my pencil up. Up means it's going towards positive infinity. So up equals positive infinity. Look at the second one. As x approaches positive infinity. That's what this is saying. As x approaches positive infinity. Okay. That means it's moving right. So again, I start at the origin to answer these questions. As x approaches positive infinity, means as I move to the right, f of x approaches what? The graph is doing what? I go to the right, and in this case I get to the arrow after I've moved to the right as far as I can, and I've been moving down. This is pointing down. I was moving my pencil down. Down is negative infinity. So as x approaches positive infinity, the graph approaches negative infinity. All the questions on our quizzes and tests will have these two questions on there, and it's asking you to address, is the graph going up or down on the two very ends of the function. The next thing we're going to ask you to do is analyze intervals. Analyzing intervals is saying, is the graph increasing or decreasing over a specific interval? You have to recognize what that means. If we're talking about it increasing, that means as I look at this very specific time period, it has a positive slope. So increasing means positive slope. Is it decreasing, which it would be then negative slope? So if it's decreasing, it has a negative slope. But we're talking about a function that curves. It keeps curving. It's going up, down, up, down, up, down. That's why we're talking about it in just an interval. When I give you this interval, I'm asking, as I look from -8, here's my -8, until I get to -2, here's my -2. Which means, and you guys don't want to do this, I'm doing this to kind of illustrate what's going on. I don't need any of this. I don't need any of this. It's all distracting. All of this part of the graph does not matter. The only part of my graph that matters is this section here that is between -8 and -2. That's what that terminology means. And as I look at the graph in that particular section, is it a positive slope or a negative slope? Remember, we read slope from left to right. Positive slope would mean the line would be going up from left to right. Negative slope means it would be going down. So as I look at just this section, it's going down. That's a negative slope, which means the function is decreasing. So now I'll kind of get rid of all of that part of it, but I'm going to put those lines back in because those lines are what helped us analyze this. It's sometimes helpful to have those in. There's nothing wrong with doing that. And then at those lines, I'll write this inequality that's been given to me. And then move to the next one. As x is between 4 and 7, I look at the graph. I'm looking at from 4 to 7 here. That's from 4, x, 7. That's when my function is in between those two values. So I'm looking at just this part. In that part, I always draw this from left to right. I drew up. That means the slope is positive, which means the function is increasing. And the last type is if I say 7 to infinity. That means I'm starting at 7, and then I'm going all the way to the arrow here. My next vertical line here to check would just be at the arrow. I don't care about this arrow. That arrow tells me nothing, because I'm focused solely on this section. And in that section it's going down. So in that section I am decreasing. The last major thing we want to talk about are identifying zeros. When I'm identifying a zero or a solution, because these are interchangeable terms and we'll spend more time on that in future videos, I'm asking where f of x equals 0 or where y equals 0. In other words, what are the x-intercepts? When I ask you for the zeros, I am asking you for the x-intercepts. All of them. Not one of them, not two of them, every time. I'm asking for this one, that one, that one, that one, that one, and that one. And we are going to always write them as ordered pairs. So I have 1, 2, 3, 4, 5, 6 zeros to represent this graph. This is at negative 10, 0. This one's at negative 6, 0. Go ahead and write your other ordered pairs. So this particular function has 6 zeros. These are all of our ordered pairs. Remember, for any number on the x-axis, any ordered pair on the x-axis, your y value is 0, so it should be in this order. It's the only one acceptable. Okay, here's the heart of the matter. This is what your test and quiz questions are going to look like. It's going to be one function, a graph with a bunch of numbers, and then a series of questions about it. This is a pretty much copy and paste of what the functions and what the questions will look like in different graphs. We're going to do a number of these, both on these notes, in class, on practice quizzes, on everything that we can do. First and foremost, I want us to talk about a problem like this. This is a way of asking you, I want this ordered pair. Fill in that blank. At 7, now the graph kind of got skewed when I printed this, but that should be right at 0. We would assume that that's a 0. So I could answer this as just 0. As my graph, my function, my x is 7, what's y? So as my graph is at negative 10, I'm at negative 10 here, what's y? I want that ordered pair. Well, again, it kind of got skewed as I printed it. It's always going to be at the numbers I give you. I'll never ask you to estimate a number. And at negative 27, we're at 0 again. For numbers 4 and 5, it goes to our end behavior. As x approaches positive infinity, that means as the graph goes right, what's happening to the function? I start on my y-axis, or at the origin, and I move to the right. I hit my function, and I keep moving to the right until I get to my arrow. This is x approaching positive infinity. I'm moving to the right, I get to my arrow. My arrow is pointing up. That's a positive infinity. So as x goes to positive infinity, my function goes to positive infinity. And then vice versa. As I go to the left, negative infinity with x, I look at my arrow for my line, or for my graph, my function, and it's pointing down. As I move left, the arrow is pointing down, my graph is going towards negative infinity. This is a little different, but this question, number 6, is really the same as numbers 1 through 3. These are the same thing. As x approaches 18, f of x approaches what? That's a fancier way of me saying, what's f of 18? It's the same thing that I'm asking. So f of 18 means, here's the ordered pair. Oh, that's at this number down here. F of 18 is negative 29. Go ahead and try our last 4 questions. So I've provided the answer to those 4. Please come to class prepared to ask questions. These are very important problems as we get to your tests and quizzes.